Hey everyone, welcome back to Anu's Chem Corner. I am Anu and today we are going to talk about salt and their properties. Some of my students have come up to me and saying salt are really confusing and salt reactions just don't make any sense. If you are one of those students, then this video is definitely for you. We'll break down all the properties of salt and how they work, everything. And also remember, this is very important while you're dealing with the titration. If you want to get the full idea about titration, first you need to crack what is buffer and the salt. In this video, we will discuss about salt and buffer we can do in another video. Let's dive into the video. Let's start acid base properties of salt. So basically, what is the salt? That's the first question, right? Salt is our normal ionic compound. Okay, what is salt? Our normal ionic compound. So our normal ionic compound, what they were doing in acids and base, right? So when acid and base react with each other, do you know what is formed? Yes, this salt is forming. Why? Because see, HA, like that you can consider a common acid, and which is reacting with a common base like BOH, you can consider just an acid base reaction. See what happened? This H and this OH will combine so that we can get B. You know, this is positive and this is negative, right? So B positive and A negative. Like that you can get it, right? With water. So see, this is a positive negative ion combo. So that is nothing but salt. An ionic compound is what we called salt. Okay. So in which you can see the B plus, the cation is comes from the base. Okay. And the anion is comes from always acid. Correct. So this is the main idea. Now let's see. So this is what kind of reaction? Do you get the reaction? Yes, this is normal neutralization reaction, or otherwise you can say double displacement reaction with acid and base. Correct? So it's a simple double displacement reaction or neutralization reaction. Got it? So the product of a neutralization reaction, acid and base, is always give a salt. So what is the nature of salt? Yes. Do you think it's always neutral? Because acid is one character, like just opposite is base. So just opposite characters are react with each other. What happen? Do you get always neutral? Yes, that's depend upon the strength of acid and base, isn't it? You can't say every time it's a neutral. It can be neutral, it can be acidic, it can be basic. Correct? Because when you are adding just plus 5 and minus 5, you got always 0, right? But sometimes plus 5 and minus 3, if you are adding, you got a positive 2. Why? Because of this acidic character, or plus 5 is dominating than the minus 3. Same effect is happening here also. Okay. So when you think about acid and base, like strong acid, strong base, so both have same strength. When it's strong acid, strong base means, 100% dissociation. Always 100% dissociation. So you got the same strength of acid and base, but opposite each other. So what happened? Definitely you will get a neutral salt. So whenever strong acid versus strong base is reacting with each other, you got a neutral salt. But what happened? One is strong and the another one is weak. Yes. So the other one is weak means in this case, see, acid is stronger one. Since acid is stronger one, definitely you can get acidic salt. Is it strong acidic? Not definitely, right? Because both are opposing, right? But the excess factor or some dominating strength is for acid, right? So that's why you can get a weak acid character salt. So this time it's not a neutral salt. Okay. So you can imagine what happened when weak acid versus strong base will be there. Then what happened? Yes, this time it will be weak basic. Correct? Weak basic salt you can get. What happened when weak acid versus weak acid, weak base? At that time, I know 90% of student will tell that will be neutral salt. Do you know the thing? It's not neutral. See, still the comparison is possible. If both are strong, there is no comparison, like 100% dissociation, 100% dissociation. So it's always neutral. But in case of weak, we can't say like that. Still, the comparison is possible. How much it is weaker, right? Weak acid is more weaker or weak base is more weaker, right? So how do you compare these things? What's the comparison factor? Yes, the Ka value, right? You can compare with the Ka and Kb value. You know, the strength of acid is determined by the Ka. If Ka is higher, higher will be the acidity. Similarly, Kb is also weak bases. How do we compare? Same. Kb is higher, then basis it is higher. So that's why still the possibility of comparison is there. So you can think if K is higher, yes, it will be a slightly what happened basic character. Okay, even a slight basic than this one, right? Slight lower basic than, like more weaker than this basic character. Okay, and yeah, if one happen Ka is lesser than Kb, yes, at that time, oh sorry, this is Ka is higher, so this is weak acid. And this time it will be weak basic. And what happen if Ka is equal to Ka? Yes, that's the only possibility. Like in weak acid, weak base case, it can be neutral at this state. Okay, so that's all actually the salt. But some students feel very discomfort, like when you read the textbook, you got some confusions. So that's why I will explain in that way. Okay, what the text says or what may be the confusing factor. In that point of view, I can explain these things once again. Okay, actually salts and base, the salt is this things are only there. Okay, so let's see what the text says. In text wordings, is there any complexities are there or not? Okay, so you may wonder with this kind of neutral ion, what is this neutral ion, that kind of stuff. Okay, so let's start once again. Salt from strong acid, strong base. Got it? Right. So I'm just erasing these things. Okay. So salt from strong acid, strong base. So as I told you, that is neutral. So why is it neutral? For example, if you are taking HCl and the strong base like NaOH, so definitely the formed salt will be NaCl. So why is it neutral? Why you are telling like it's neutral? That's the reason. That's the reason they were explaining. Okay. So you know that this is a strong acid. Strong acid, the formed conjugate base will be negligible. Do you remember? We have studied that one. Every time a conjugate or the partner, conjugate acid or the conjugate base formed from a strong thing, then the effect is negligible. Only weak acid can provide weak conjugate base, or weak base can provide weak conjugate acid, like that. Okay, since here Cl minus comes from the HCl, Cl minus is negligible. Similarly, Na plus comes from NaOH, like strong acid. So Na plus is also negligible. So both of them is negligible. That's why we are telling it's neutral. They are not contributing to the pH. Okay, so you can say Na plus is a neutral ion. Cl minus is also a neutral ion. So what are the other neutral ions? Whenever these neutral ions are there, you can just tell those are like neutral property, like they were not contributing any pH. Okay, so what are the like other neutral ion? Because you know all the counter like anions of a strong acid, definitely it will be neutral. Correct. So what are the other strong acids? We studied HCl and HBr, Hi, so Br minus, I minus, Cl minus. Similarly, other strong acids are HNO3, nitric acid, and H2SO4, so SO4 2 minus, and HClO4, perchloric acid, so perchlorate, and what's the other one? Last one, chloric acid, ClO3. So this is chloride ion. So these all are, the anions comes from the strong acid. So these all are neutral ions. Okay, so from, as I told you, anion is always come from acid. So similarly, what are the strong base? List of strong base. Yes, group 1 cations. All the group 1 cations, like group 1 hydroxide is, isn't it? Group 1 hydroxide is strong base. Similarly, Ca2 plus group 2, in group 2 calcium and barium, similarly strontium. These are the three, like their hydroxide is also strong base. So definitely group 1 cations are neutral, like Na plus, Li plus, K plus, like that, Cs plus, francium plus, like that. And group 2, what are them? Ca2 plus, Ba2 plus, Sr2 plus. So these are the list of neutral ion. Did you got the idea? So when they were talking about neutral ion, this is the meaning. Okay, right. Then, so neutral ion have no effect. Got it? Then, let's move on to the next one. See, salt that produce basic solution. Salt that produce basic solution, which means you already imagine that acid and base, which is strong and which is weak. Okay, so weak is the acid. So I can take NHF, basic. So NaOH I am again taking. So this time I got NaF, isn't it? So what kind of salt is this one? Yes, this is basic salt. Correct. So what is the reason for this one is making like being a basic salt? Yes, you already know. This is basic salt. Is it because of Na plus? No, right? Na, even this is strong base. So that's why you got a basic salt. But actually the basic nature of this NaF is not like Na plus. It is actually F minus, isn't it? Why I am telling like that? The reason for their basicity is F minus. Why? Because yes, Na plus it's already formed from a strong base. It's formed from a strong base. So strong base means this is negligible. Na plus is negligible in its effect. Or it's a neutral ion. You can say it's neutral ion. Then who is non-neutral? Yes, F minus, because it comes from a weak acid. Okay, so you can say the cation is a neutral property, and anion is comes from a conjugate, or anion is a conjugate base, comes from a weak acid, is basic. Correct? So whenever we want to write the salt equation, or when you are studying the titration, you need to write the salt equation, salt ice table, salt dissociation. At that time, NaF, the whole thing you don't want to take, you can just take F minus, because Na plus you don't want to consider, just like a spectator or just like a neutral ion. Okay, so how do you write F minus reaction? How do you write base dissociation equation? Yes, you can write the base dissociation equation as I already discussed in titration. Yeah, if you have any doubt with the titration, you can just check my video. Okay, in titration, you may wonder like if an F is formed, why I am taking just F minus. So this is the reason. Okay, the actual reason for their basicity is F minus. So how do you write F minus reaction? Base dissociation equation. Yeah, it's a base, not the point, it's base. So you need to show the reaction which is taking H plus, isn't it? Because we know that base means they were accepting H plus. Acid means they were donating F minus, sorry, H plus. Okay, so F minus you can write H2O. Why I am taking H2O? Because I need to show F minus is taking H plus. They were accepting H plus. So if no one is there to donate H plus, you can just add one H2O. So that you can show H2O is donating the H plus to F minus. So H2O is acting like an acid. Okay. So the formed species will be HF and OH minus. So see, they were forming OH minus. So that's why it will be a basic character. Got it? So this is how you need to write a salt reaction. So if you want to show why F minus is salt, so F minus is base, you can just add with water and you can show that the OH minus is forming. That's all. So that's the thing. So that's why I'm telling this kind of wording, like any salt whose cation has neutral properties and whose anion is conjugate base of weak acid, the aqueous solution will be basic. If these kind of terms may be difficult for you, that's why I'm telling like this. Okay. Now I think it's you got the idea. Okay. If any doubts are there, just comment below. Okay. So see, the same thing you can apply with a salt that produce acidic solution. So this time I need to take a strong acid. So I will take HCl and a weak base. I can take NH3. So that what happen? Yes, NH4 Cl is formed as a salt. So here who is the reason for their what kind of salt? Definitely this is strong acid and this is weak base. So definitely my salt will be an acidic nature. So this is acidic nature. So who is responsible for acidic nature? Is it NH4 plus or Cl minus? Now you know the answer, right? Because Cl minus is a neutral. It's negligible because it's formed from a HCl, right? So strong acid. So here the reason for their acidity is NH4 plus. Okay, so you can show NH4 plus reaction. NH4 plus reaction for acid dissociation, it's very easy. You can just show like this. Like NH, they are just dissociating. H plus, they are giving just H plus like that. You can show. Sorry, there is no H plus here. Okay, or if you want to write like NH4 plus H2O, you can write no issue. At that time also H2O is accepting H plus. So the formed species is NH3 plus H3O plus. Hydronium ion will form. Both are correct. You can show like acid dissociation equation like first way or second way. So if you want to show the basic acidic character of the salt, this is the way of showing that one. Okay, so this is the salt reaction. Clear? So here who is responsible for the acidic nature? Definitely the cation formed from a weak base, isn't it? So that's why we are telling like that. So in this case, anion is formed from a strong acid which is neutral. Clear? I hope you understood. So then we can move on to the last case, which is salt is from weak acid and weak base. Okay. So this time, yes, both are weak. I already told if both are weak, it doesn't mean it is always neutral. At that time also, the comparison is possible. So whenever Ka is higher, you have to take acidic. If Kb is higher, you have to take the salt as basic. If K is equal to Kb, that's the only time you can take it like a neutral. Okay, that's it. Now there is a work for you. Can you able to calculate is it acidic property or basic property? Like for example, if this is your salt, yeah, I can give only one assignment for you. If this is your salt, how do you tell? What may be the nature? Is it acid or neutral or basic salt? How do you tell? Okay, let's crack it up. So here, first of all, two ions are there. One is NH4 plus and the other one is acetate ion C2H3O2 minus. Which one is acid? Yes, NH4 plus is acid, right? This is the acid ion. So, is either of this one is neutral? We studied a list of neutral ions. Did you remember? See the list of neutral ions. In these neutral ions, there is no NH4 plus or acetate ion. Correct? Which means none of them is neutral. At that time, what is the thing? Both are weak. If both are weak, what you want to do? You have to calculate the Ka, compare the Ka. So since this is acid, Ka of NH4 plus is there and this is basic thing. So this is Kb. Correct? Acetate ion. It's formed from acetic acid. So this is the conjugate base. Do you understand why I am telling this is base? This is the conjugate base of acetic acid. Similarly, this is the conjugate acid of ammonia. Okay, so they have a Ka value and this will have a Kb value. So see the table. NH4 plus. Did you see the NH4 plus? Yes, here. NH4 plus is there. So the Ka value is also given like this. Okay. Then Kb of this one. Kb value they were not given. Okay, what they were given is acetic acid. Acetic acid Ka value is given. So do not compare this and this. This and this is not comparing, right? KB, we need KB. KA is okay, but we need KB. So how do you get KB? You can do that, the K and KB relationship. Ka times KB is equal to 1 times 10 to the power of negative 14, that KW value, right? So you can calculate KB like that way. 1 times 10 to the power of negative 14 divided by 1.8 times 10 to the power of minus 5. So while you're doing this, you can get the same like 5.5 or 5.6 times 10 to the power of minus 10. So in this case, you got the same value. Okay. So here Ka is equal to Kb. That's why you can say Ka is equal to Kb. That's why you can say this is neutral salt. Otherwise, you can't. Okay. So this is the way you have to calculate. Is it a neutral or uh, basic or acidic like that? Okay. If it's so, can you tell me, see, for example, if NH4 or NH4Cl is the thing, how do you tell? Yes, NH4Cl, what happens? Cl minus is also neutral. So you don't want to consider this one and you can consider with this one, isn't it? So NH4 plus. So NH4 plus is a basic character. So definitely it's a basic salt. Sorry, NH4 plus is acidic character. So definitely it is acidic character. Okay, so this one is acid. Like that, if neutral ions are there, you can just ignore that one and consider the other property. If both are not neutral, then you have to compare the Ka and Kb. If both are neutral, then the salt as a whole is also neutral. So that's all about this one. Okay, right. Alright, that's a wrap on our deep dive into salts and their properties. I hope this cleared up some of the confusions and gave you a better understanding of how salt work in their chemical reaction. If you found this video helpful, don't forget to like, share and subscribe to Anu's Chem Corner for more chemistry tips. Drop any questions or comment below. I'll be happy to help you. Thanks for watching and I will see you in next one.